Welcome to G Fun Facts Online, where we dive deep into the science shaping our world. Today, we're talking about a silent war happening in fields and farms all around you. It's a battle for our food supply, fought with weapons so sophisticated, they sound like something out of science fiction. But this new technology might have an unintended dark side, one that connects to the mysterious disappearance of honeybees. Let's get into it. For decades, when farmers had a pest problem, the solution was simple. Spray everything with powerful neurotoxic insecticides. These were the sledgehammers of pest control, killing the bad bugs, but also causing a lot of collateral damage to beneficial insects, the environment, and even our own health. In response, scientists developed a smarter, more tactical approach: Insect Growth Regulators, or IGRs. Think of IGRs as a form of biochemical warfare designed specifically for insects. Instead of a quick, messy kill, they disrupt an insect's very life cycle. They're slower, taking up to 2 weeks to work, but they dismantle a pest population from the inside out. There are 3 main types. First, you have juvenile hormone analogs. These chemicals basically trick an insect's body into thinking it should stay a larva forever. It's like a Peter Pan pesticide. The bug never grows up, can't reproduce, and the infestation dies out. Second are the chitin synthesis inhibitors. Chitin is the tough material that makes up an insect's exoskeleton. As an insect grows, it has to molt, shedding its old skeleton. These inhibitors block the creation of new chitin, so when the insect molts, its new skeleton is weak and defective, and it can't survive. It's like trying to build a suit of armor out of wet paper. Finally, there are ecdysone agonists. Ecdysone is the natural hormone that tells an insect it's time to molt. These agonists mimic that hormone, but trigger the molting process way too early. The insect is forced to molt before it's ready, a process which is ultimately lethal. Now, this all sounds great, right? Targeted, less toxic to mammals, and even labeled reduced risk by the EPA. And in many ways, they are a huge improvement. But here's where the story gets complicated. The specificity of these IGRs isn't absolute. While they are designed for arthropods, honeybees are also arthropods. Some studies suggest that while these chemicals might not kill bees outright, they can have subtle, damaging effects. For example, some juvenile hormone analogs can make bees start foraging for food too early in their lives, which can shorten their overall lifespan. Others have been shown to disrupt the social behavior of bees, making it harder for them to be accepted by their own nestmates, which can cripple a colony's growth. This brings us to one of the biggest ecological mysteries of the 21st century: colony collapse disorder, or CCD. Starting in the early 2000s, beekeepers began reporting something truly eerie. They would check on their hives to find them nearly empty. The adult bees had vanished, leaving behind a healthy queen, baby bees, and plenty of food. It's like the entire workforce of a city just disappeared overnight. The cause is still a puzzle, but scientists agree it's not one single thing. It's a death by 1,000 cuts. The prime suspects include other pesticides, particularly neonicotinoids, which can damage a bee's immune system and navigation skills. Then there are parasites, like the devastating varroa mite, which is like a vampire that also transmits deadly viruses. Add in poor nutrition from vast fields of single crops, and stress from being trucked across the country to pollinate different farms. Now, is there a direct, proven link between IGRs and CCD? No, not definitively. But in this complex web of stressors, IGRs could be acting as another sublethal blow, weakening the colony just enough for another factor to finish it off. So what's the path forward? The answer lies in a more holistic approach called Integrated Pest Management, or IPM. It's about using a combination of smart strategies. This includes cultural controls, like rotating crops to break pest cycles. It means using biological controls, like releasing natural predators to eat the pests. It involves physical barriers and traps, And when pesticides are absolutely necessary, it means using the least toxic option in the most targeted way possible. The future is even more exciting. Scientists are developing things like RNA interference, which could create pesticides so specific they only target a single species of pest. We're also getting better at producing synthetic insect pheromones to disrupt mating and using AI-powered drones and cameras to spot and treat pest problems with incredible precision. Insect growth regulators are a major leap forward in pest control, but the mystery of colony collapse disorder is a stark reminder that our ecosystems are incredibly delicate. We can't afford to solve one problem by accidentally creating another. As we continue to innovate, we must remain vigilant, always working to protect the tiny pollinators who are so essential to our food supply and the health of our planet. Thanks for tuning in to Fun Facts Online.